And so we're given a 4 function f, g, h, and k. And let's look at the first part. We're asked to find the value of f of 2 plus h of negative 3. So we want to work out h of negative 3 as well as f of negative 2. Let's do the first one, f of negative 2. So we look for the function f, and the function f is f maps x onto 3x minus 1. So that really means f of x is equal to 3x minus 1. That's all it's saying. And so to find f of 2, we replace the x, the input value, being 2 there. So wherever we have x, we put 2. And we work out the right hand side. So 3 times 2, since x is 2, will give us 6 minus 1. That gives us 5. Now let us find h of negative 3. So we call the h function. And instead of writing it in the mapping form, we write it as the equation form, h of x. Next step, we replace the x with the input value of negative 3. You know, it's good to put brackets when you have a variable. But what would happen here if you put or replace the x with negative 3? You can just simply say, this is saying x plus 5. And since x is negative 3, it's really negative 3 plus 5. If you want, you can think of this as a 1x. So it's really 1 multiplying by the x value. But still, 1 times negative 3 still gives us negative 3. But simplifying this, we're going to have 2 times negative 3 is a negative 6. And negative 6 plus 7, that will give us a 1. 1 times negative 3 is negative 3. And negative 3 plus 5 is a positive 2. Now it's important that you understand how we got this half. If not, you can use your calculator. Work out the numerator, work out the denominator, and that should be your answer. So our solution will be the f of 2, which is worked out to be 5, plus the h of negative 3, which worked out to be a half. And of course, 5 plus a half is simply 5 and a half. So this is our solution. Now we want to work out the value of the composite function g of h of negative 3. So what we do, we will basically recall that we worked out this portion already, the h of negative 3. And h of negative 3 is a half. So what we're really working out is g of what? G of a half. Did you get that? H of negative 3 is a half. And if you look in the bracket here, we're seeing h of negative 3. So h of negative 3 was worked out to be a half. So we need to just simply replace h of negative 3 with a half. So in fact, we're finding g of a half. So now we're looking at the g function. And what's the g function? 2x plus 5. So we call the g function, which is g of x equal 2x plus 5. And we're going to input, let's put it here, g of x here now being the half, that's our input value, which is representing h of negative 3. And so it's going to be 2 times a half plus 5. Now how do we work out 2 times a half? Now this is saying 2 times a half, which really means half of 2. And half of 2 is 1 plus 5, and that gives us 6. If you want to see some calculations in terms of computation, how we do that, 2 multiplied by a half, let's put the 2 over 1. Now 2 times 1 gives us 2 in the numerator, 1 times 2 gives us 2 in the denominator, and 2 divided by 2 is 1. We could have also simplified the numerator with the denominator by saying 2 into 2 goes once and 2 into 2 goes once. And so that's 1 times 1 gives us 1 over 1. So this is our solution, 6. F squared of 2 is f of f, that's where the squared comes from, of 2. So f squared really simply means f of f. It doesn't mean we're squaring anything. Now given that's what it means, we can, translate this a little better. We can say it means f of the solution to f of 2. So we find f of 2 and we put it in the function f. So let's do that now. Now, if looking at f of 2, we already worked that out since it's based on these functions that we have at the top. What is f of 2? When we put 2 in the function f, we get 6, and then 6 minus 1. That gives us 5. And if we look at this, we actually see that we actually did work out f of 2, and we got 5. So that's exactly what we're going to basically use. So f of 2 is the same thing as 5. So we're replacing f of 2 with 5. So now we have the input value being 5 in the function f, because f of 2 can be replaced with 5. So it's 5 in f. So let's go for the function f. And the function f is f of x is equal to 3x minus 1. So now what we're going to do, we're going to replace this x with 5, because it's saying f of 5 instead of f of x. So f of 5 is equal to 3 times the x value, which being 5, minus 1. This gives us 15 minus 1, and this gives us 14. So this is our solution. Now let's look at this now. The value of the composite function g of f of 2. Now this is similar to the previous one, but notice that we have g of f of 2. So this is really saying that we want f of 2 within g. So we know what f of 2 is. We worked that out already. What was f of 2? Going back to this example, f of 2 is 5, so we know that f of 2 is really 5. So replacing f of 2 here with 5, so it's g of 5. Now which function do we enter 5 in? According to this, the g function. So the g function is what? 2x plus 5. So the g function is 2x plus 5. And our x value here is what? 5. So it's g of 5, replacing x with 5, equals 2 times 5 plus 5. That gives us 10 plus 5, which gives us 15. So that's our answer. So we can say g of f of 2 is equal to 15. Now let's look at this one. We want to write an expression for the inverse of f, which is written like this. F inverse, the negative 1 as power really means inverse. So we say f of negative 1? No, we say f inverse of x. All right, so to find the inverse of f, we need to look at the f function first. The f function, the original function of f, is equal to 3x minus 1. So how do we get to f inverse? Well, there are some steps. Step 1, change f of x to y. So let's do that. We're going to change this f of x to y and write it out as equal to 3x minus 1. What's the next step after that? The next step is to replace y with x and replace x with y. So we're interchanging x and y. So wherever y I put, that's correct, x. What, the 3? Wherever x I put what? Y. What, minus 1. Now what do I do after this step? Let's go over the steps again. We start with the original function of f of x equal 3x minus 1. Step 1, replace the f of x with y and write back the rest of the function. Next, we interchange x and y. So I'm going to have x equal 3y minus 1, as we have here. We interchange the x and y. So what's the next step? The next step is to make this y the subject. So we want to isolate this y. So now recall that we have what? We have that x equal to 3y minus 1. So we want to make this y the subject. So we're going to transpose the minus 1 over. And that will leave us with x plus 1. Why plus 1? Do you know? Because the minus 1 has been moved from one side of the equal sign, from the right hand side that is, to the left hand side. So once you move from one side to the next, from the left to the right of the equal sign, the sign changes. Either from the left to right or right to left. The sign of operation changes. So x plus 1 will be equal to 3y. Now I need to get rid of this 3 from before the y. Now this 3 here is what operation being carried out? Multiplication. So to get rid of this 3, we will divide both sides by 3. And so this will give us what? This will give us y equal to x plus 1 over 3. And I'm sure if you look at the original equation, 3x minus 1, you can see where the minus 1 become a plus 1, and multiplying by 3 becomes dividing by 3. But we're not done yet. We want to write this y as the inverse. Remember, this y represented f of x. So this y will represent the inverse of f of x, which is x plus 1 over 3. So if it's simple like this, you can actually go from the original function straight to the inverse without going through these steps. If it's this simple. All right, so that's our inverse of f of x. Let's go on to the next question. This is asking us to evaluate or find the value of f inverse of a half. This half cannot go into the original function of f. It must go into what? The inverse function. We've seen this is saying inverse. So we want to ensure that we're using the inverse function. So we just don't want to go and input using the wrong function. It says inverse, so we need to use the inverse function. And we did find the inverse function. The inverse function is x plus 1 over 3. So let's write that. The inverse function of f is x plus 1 divided by 3. So what we're going to do, we're going to replace this x now with a half. So it reads f inverse of a half. So replacing this x with a half, we say it's equal to, where we have x here, we're going to put a half plus 1 divided by 3. Now, of course, you know this is going to be what? What's a half plus 1? That's 1.5. 1.5. Let's write that. A half plus 1 is equal to 1.5. And of course, you can write that as 2 ones, 2 plus 1, 3 over 2. So that's 3. So half plus 1 is 3 over 2 divided by what? Divided by 3. So what we can do, we can get rid of the denominator here by multiplying this fraction by 2 over 1. Also multiply by 2 over 1 as well. So what this does, it cancels out the 2's. So what we have is 3 over 6. And 3 over 6 can be simplified as 3 into 3 goes once and 3 into 6 goes twice. So that's a half. So our answer, f inverse of a half, is actually a half. Let's find f inverse of 3/4. So again, we're dealing with the inverse function. So we look for the inverse function and not this original function since we're talking about inverse. So I'll have the inverse function. I'll get that function which we worked out already. And we replace this x with the input value of 3 over 4 or 3/4. All right, so we'll have this will give us what? Let me just write it here. Replacing x with 3/4. All right, so now what is 1 plus 3/4? 1 and 3/4 divided by 3. And 1 and 3/4, we can actually write that out. Let's write that out. Let's write out the numerator as a improper fraction. 4 ones 4 plus 3, that's 7 over 4. All divided by 3. Now, as I did in this example here, to get rid of this 4 is to multiply the numerator by 4 over 1. So it allows us to cancel denominator with numerator, give us 1. And then we also multiply this by 4 over 1 as well. So this will be equal to, since we have 1 times 7 is 7, and 3/4, that gives us 12. And of course, this cannot be simplified any further, so our answer is 7 over 12. Determine the value of x, which makes the following function undefined. H of x is equal to what? 2x plus 7 over x plus 5. So a function is undefined if the denominator is equal to 0. Denominator here is actually x plus 5. And so we set it equal to 0. But what is the value of x that will make this expression here 0? That's correct. X would have to be -5. No, so what we're going to do, we're going to say x is equal to, I will subtract this 5 from this side, leaving me with x. And then I will also subtract 5 from this side as well, and that will leave me with -5. So you can think of it as this +5 being transposed to the right hand side from +5 to -5 on the other side. So x is equal to -5. All right, what about this one? K of x. In other words, what would be the value of x? What value of x will we put here? That when we put it in this function, it actually works out to something over 0, which means that it will be undefined as well. So what we do, again, let's write the function 7x plus 1 over 5x minus 1. Take the denominator, 5x minus 1, set it equal to 0. Now we need to find what x is, what the value of x will have to be to get this to be 0. In other words, the denominator will become 0. Step 1, transpose the minus 1 over, and this will give us 5x. The minus 1 goes over as what? Plus 1, so that's 0 plus 1, which is 1. Or we could say we add 1 to this side, we add 1 to this side, so this will cancel out, leaving us with 5x equal 0 plus 1, 1. 5x equal 1. So we're going to divide by 5 to give us 1x. We also do the same thing to the other side. So what we have here is that x will have to be 1/5. It says here, using the function f of x equal 3x minus 1, which is this function, f function, determine the values of a and b for the mapping diagram below. So this is saying f maps the x values onto the y values. So these are our x values, these are our y values. When the value of x is 3, what is the value of y? We have a there to represent it. So we take the function f of x being equal to 3x minus 1, and the input value there is going to be 3. So it's 3 times 3 minus 1. That will become 9 minus 1. That will be equal to 8. So in other words, a is equal to 8. You can use this mean, therefore a is equal to 8. For b, what is b? Now we're actually going from the y to the, we're given the y value, so we need to get the x value, so we're actually doing the reverse. And when we're doing the reverse, we use the inverse function. Remember, we found the inverse of f of x. The inverse of f of x is equal to x plus 1 over 3. So when we're going from the y to the x, we use the inverse function. Y became x. Remember, we interchange x and y when we're trying to find the inverse. So that's exactly what happened here. So we can afford to replace this x with -7 because y became x. And so we'll have -7 plus 1 over 3. This will give us what? -6. Signs are different, so we subtract. We have more negatives, so that's -6 over 3, and that's -2. So b equal -2, because we put 7 into the inverse function means reverse, and so we'll get -2. But can we prove it though? Well, if we put -2 in the original function, let's see what happens. 3 times -2 minus 1, this will give us -6 minus 1. The signs are the same, so we add and keep the sign, -7. So we're seeing it actually worked. When b is actually x is equal to b, which is really -2, put it in the original function, we do get -7.